Welcome to Aline, who's our presenter for today, and she's going to be talking about modeling pastoral mobility in the West Sahel.
Yes, thank you for the introduction. So indeed, what I'm going to be talking about is mobility. I'm going to start with first explaining a bit why this is a problem, specifically for pastoralists, why climate change has become an issue in the way they live, and how migration models have tried to deal with this already. Then I'm going to present what I call my ideal solution in the hopefully very end of my PhD, which is a pastoral modeling framework, talking about some existing data sets, using perceptions as the starting point, and touching a little bit on something that might potentially become a causal graph later on, and then what I've actually done so far, because the middle part is a bit more of like ideas and philosophy. So first of all, the problem. We're talking about the West Sahel. Apologies for the resolution of the map. But basically, we're looking at the part in the west, upper west region, between the dry Sahara in the north and the more like lush, humid savanna in the middle part of Africa. In between, there is a belt which is called the Sahel region, and about 12 countries are part of this region. And what is very interesting about this region is that there's only very, very few actual cities. So the like white stars, even though it might seem like a lot on the scale of 12 countries, there's actually very few big cities, which means that 86 to 80% of the people are estimated to be living in rural areas, and they make a living from either being farmers or herders. Any case, they depend a lot on the seasons and the environment and the way they live. And one big aspect, which I'll also talk a lot about later on, is the seasonal rainfall. So there is a dry season and a wet season for different countries, and even within countries, the exact start and end of these dry and wet seasons are different. But there's always a notion of these like two kind of different dynamics. And the region for visualization looks more or less like this. So it's a like semi-arid region where people would move around based on the availability of certain resources in order to be able to sustain themselves and or their herd. This is a map that is showing more or less what the definition of a pastoralist is. These are basically under the category of rivers, a type of agriculturalists who move around with the seasons. So they would mostly reside in the north, which is the like blue indicated region, the Sahel region. And whenever it gets too dry there, they would migrate towards the south because there would be more vegetation available. And then whenever the vegetation is kind of regrown in their region of origin, they would move backwards to the north. So there is this like north-south movement aligned with the wet and the dry seasons. And this has for like decades or even longer than that kind of work pretty well together, in a sense that pastoralists would move further south and make use of the crop residues from farmers who are having their agricultural feeds there and will have just harvested before the pastoralists arrive. And then by the time the pastoralists start moving back north, the livestock manure is then a very good nutritional source for the farmers, which then creates a mutually sustainable system between the pastoralists and farmers. Obviously, if this was the end of the story, I wouldn't be here presenting my PhD. So there has to be a kind of issue that has to be brought into the story. As we can see on this summary of the IPCC reports, there have been some changes in the region in various variables. I've just taken out the temperature and the precipitation ones, which are already showing that there are large changes already happening historically and also to be projected for the future. One specific interesting one that I'll just quickly touch upon is the precipitation, where I've here kind of projected the mean precipitation change as predicted by one of the climate models. And this one is, it's a bit counterintuitive, but the blue regions are the regions in which we're expecting rainfall to increase, and the red ones are the ones where we're expecting it to decrease. So there's kind of two opposing systems at different timescales at place, of which one is the fast response, where increasing CO2 levels kind of make the gradient between the northern and the southern hemisphere more extreme, which then causes a northern movement of the monsoon system, which is the rainfall system, and increase of precipitation, while on the other hand, a change in ocean circulations, therefore a change in sea surface temperature, does the opposite and pushes the monsoon system downwards, but this is a more gradual response over centuries. And even though climate models agree that these both systems are at play, they do not quite agree on at which timeframes they will overlap. And if anything, one thing we can be sure of is that precipitation and other variables in this region are changing and will be changing a lot, which then causes issues for the other story that I was talking about earlier, which is this movement of pastoralists. If we imagine that there are pastoralists, in this case in Mali, and they would be moving more towards the southern border of Mali, Burkina Faso in the dry season, And they would do so moving more or less around October to the south, and they move back up north around, let's say, May, June. If we have a change in precipitation patterns and they cannot find the vegetation that they do want to find in the dry season, they might be tended to move further south, so they would end up further into the regions of Burkina Faso or the north of Ghana even. And this could not only change in like terms of spatial patterns, but also in terms of temporal patterns. So they might decide to stay longer in the southern regions and return back up north later if there wasn't enough vegetation available in that more northern region yet. Which then, as you can imagine, creates conflicts because the farmers who want to use the same land in the other times of the year would not be so happy that the pastoralists are arriving earlier or staying longer, or even in extreme cases, never moving back up north at all, and kind of getting this semi-permanent settled status. So this gives a lot of issues in terms of resource competition, land ownerships, but also road encroachments, as farmers would then start to build their farmer lands specifically over the roads that used to be historically used by the pastoralists. And this map is just a projection of violent events reported in the region, I think, over the last 5 years, just to show that there is clearly an issue that has to be dealt with, or at least analyzed. Then I had a quick look into migration models in the region to kind of see if there's a way that these dynamics are already being mapped. And what I found, I'm not going to go into the details of all these models, but upon trying to reproduce some of those, talking with the authors and organizations that have developed these, most of these models focus on the very large scale. So they would be looking at population scales of like a whole country and how many people have moved in and out, or they would look at yearly scales or even decadal scales, like the migration hotspots where we're just trying to predict where people will be in 50 years' time, or a risk of displacement according to a gridded index, but none of them really touches upon this, like what happens intra-seasonally. We have a small model developed by World Pop where they're trying to map it, but this model is not, I'm trying to remember, this model is not making use of actual numbers of pastoralists being in certain regions, but just tries to deduce it from, I think, satellite variables. So in any case, the conclusion of this is that there is not really a model sitting at this specific intersection of climate migration, climate change, and pastoral dynamics, which then brings me to the questions that I set myself up to do this research around, which is firstly looking at how historically seasonal patterns have changed over time and how these can be linked to indicators such as maybe potentially a changing start and end of the wet or dry season. Secondly, how these spatial routes then have changed in the response to climate variation and if there's changes in specific directional trends. So this is looking a bit more at the actual regions people are looking at moving to. And then the last one would be, out of this more historical mapping and analysis, can we deduce some critical climate variables that have historically triggered these changes, and how can these then hopefully inform potential future tipping points, or can we deduce where people might be going? In an ideal case, we would just, this is also what I started my research of, hoping that I could just throw in a bunch of climate variables, have on the other hand a whole lot of information about mobility trends, and then I have the magical AI machine learning model in between to figure out what the links are in between. The biggest issue with that approach is that we do not have actual good data on mobility trends, and the best map existing on where people have moved historically is this map by IOM, the International Organization of Migration, and every other research source that I would find is referring back to this map. Well, the issue with this map is that this has been produced by a person sitting in IOM at an office based on his personal experience, and therefore all these dots where I was hoping that where they are starting from and going to will point to a specific place that actually just kind of randomly put into PowerPoint. And this is what everybody is basing themselves off to know what the trends historically have been. I've tried to chase the data that IOM is collecting to recreate this map myself in a way that I could then hopefully use this for some kind of more data-informed mapping. But when I tried to do this, I spent about a month trying to clean up this data set, which has a lot of interviews where people from IOM have asked people where they have moved, where they came from, where they're going to in different months, I think. But the names of the regions would be in French, would be in English or other local languages. Sometimes they would use administrative codes instead of the actual names. So just cleaning up the data set took up so much time. And then if I would take out the data points, which would just be like one person, I think 3 people or less, I would consider it a non-significant migration trend, and that's even a very low threshold. The only directional flows that I would end up with are the ones plotted on the map above, where I split them up in, on the left, dry season, so the let's say the months that I identified people moving as it being a dry season, and on the right, the wet season movement. So we can, if we squeeze our eyes really hard, kind of see this northward movement on the wet season and the more southward movement on the dry season, but not even in a way that I could hope that my model would be able to take something out from there that is more informative than what we can just see by our eyes on this map. Other data sources that I try to look for, I'm not going to go over all of them, but there's been a long period of research on all potential migration data, of which another interesting one is this one from an organization called ACF. They have pastoral sentinels, which are people physically on the field that have agreed to answer questions about their migration and their cattle status every month in terms of answering to phone text. So they would be saying the cattle overweight stage, or things like, have people departed early? Is there been a mass departure? Has there been a forced departure? And then these answers get back into a big spreadsheet, and I've tried to translate those into metrics, like here where I plotted the locations of the people according to the latitudes, and then the different categories in time on another scale, so that I could try to deduce that maybe in specific years and specific months, everybody answered that everybody was moving early, but also from an initial point of view, there is not as much trends that I can deduce from here. So I kind of got stuck in my initial idea of building a model the traditional way. So then decided to take another approach, in which we start from perceptions. What do I mean with this? This is mainly built on the idea that most objects or most subjects that we study with machine learning are study subjects that we can only deduce certain information from the data itself. Well, actually, if I'm studying humans, humans have the unique aspect that they can talk and they can explain me why they're moving somewhere and when they were moving and how they were planning to do that in the future. So I've talked with many people and collected based on these information on two different fronts. One is the actual mobility trends, like in this year we've moved from there to there, or in the last few years we've been moving further south or further east or whatever it is. And the other part is mediating variables, which then in my initial idea of going from climate variables to mobility trends introduces another notion of data aspects that I might not have directly thought about when I was putting my data sets together. Out of these, I can then, I will go into some examples later, formulate some hypotheses that try to capture these perceptions of mobility trends and mediating variables and kind of connect them to data sets that I could quantitatively measure instead of it just being like a qualitative quote. And then if I try to validate these, then hopefully it can give me some criteria that I need to link climate variables to mediating variables, and then further up the same with bringing these mediating variables into mobility trends. If you're now wondering, this is a nice conceptual framework, but what does this actually mean?
So just okay.
Yeah, go ahead.
And you have the mobility
Yeah.
trends, you say this talk to quite a few people, right?
Yeah.
What if they contradict each other?
There is big contradictions in these,
Yeah.
which is something I will have to deal with in the validating aspect. So this is,
But if you can have contradiction, you can validate anything.
sorry?
You can if you have a contradiction in your data, you can validate.
Oh, in my data.
Not in the mobility trends information,
Yeah.
right? Then you can validate whatever you want because, well, according to them, this is correct. According to somebody else, it's wrong.
Mhm.
Which one do you pick?
I'm not as far into my analysis of the mobility trends yet to have thought about that aspect yet.
Okay.
I'm just looking for now at the climate variables to mediating variables for
Okay.
now, but
Okay,
it's
okay.
a very valid point.
Mm.
Yeah, for now I'm just a bit more on the earlier aspect. So if we have this conceptual framework, let's say, and we looked at how I first translated these mediating variables into a scheme. This is one that I made based on pastoralists in Nigeria, and they would just do long conversations that I then tried to narrow down to a kind of framework with variables in between, where on the left I would ideally start with my climate variables, on the right what makes them move, and then the highlighted ones are the ones that they actually would explain to me as the ones that inform their decision. For example, is the road accessible? Is there enough water? And do I have enough pasture? And they don't actually care about it raining or it being hotter. They care about how it physically outputs to something that makes them take a decision on moving. And I'm expanding this, I'm planning to expand this to other regions and other countries, and also I'm planning to do some field work to have this a bit more locally grounded, because for now it's just based off of the accidental people that I could reach online or talk with. But if I then take these, and then go to the actual hypotheses, here are a few examples of what I was talking about earlier. For example, these would be quotes like rain started earlier than it used to, which then confuses the farmers and creates conflict. I try to formulate these into very tangible quotes, like we can see on the right. If the dry season has become wetter over time, then the distribution of the precipitation in the 2 weeks prior to the traditional start of the wet season should show a progressively longer upper tail. So it's basically a way to translate human conversations into more quantitative quotes, which is a bit of a tricky process, and I'm just in the very, very early stages of looking into those related to pasture. But it's at least a way that I try to bring the perceptions into my potential modeling. And as I have to admit, I'm not like in this scheme, I haven't really looked at the part with the mobility trends yet, because that's the part where I got kind of stuck on my data set. So I decided to look at the bottom part first, because that's at least something that can give an indication of those variables that might be needed for the people locally to make their decision. And it could be even as far as like, in my research myself, I would ideally have a model that could go from climate variables all the way to mobility trends. But for pastoralists themselves, it doesn't matter as much what I'm predicting them to be moving towards to, but they care about what those mediating variables are going to look like. So therefore, I picked one of those mediating variables, which in this case is the pasture availability, and just try to look at how this, first of all, spatially has changed over the last 25 years, because that's the data that I have with the MODIS data set. And this is a map showing the change in the past 25 years, the slope of change of a mean over all the data points that I had, in which the narrative of desertification, which is the most commonly used when talking about vegetation in the Sahel region, is already a bit more nuanced than it would be in most of the aspects that I'm looking at. Sorry, I got lost for a second. So instead of, this is the plot that belongs to the red regions are the places where vegetation has decreased, and the green ones are the places where vegetation has increased. But the issue that we're just looking at a map like this is that there is a much larger time scale that probably we want to look at, more than the 25 years of data that I have available. There is opposing signals, and then also that this doesn't really reflect the seasonal changes itself, because it just looks at the change of NDVI in the last 25 years. So then I picked two countries, the countries in which I've talked with some people, to look at the specific changes per month. And in these ones, you can already see the blue highlighted ones are the ones that are in the wet season. That we can see that the vegetation is actually only substantially decreasing during the wet season, but during the dry season has kind of stayed the same as it was before, or at least the changes are not as significant. And then we have a similar trend when we look at Ghana. And in Ghana specifically, I'm in the early stages of looking at mapping some historical timelines and some hypotheses that I have there from two my data products. And in these, we know that historically there didn't used to be any pastoralists in Ghana, but only the last few years, because of the southward movement, people are slowly encroaching more into this region. And we can kind of see this from the vegetation decreasing in a way here in the north during the wet season, and then it gradually shifting further downwards. But it's a bit difficult to just link this timeline, which goes over like, let's say 50 years.
It gets less vegetation when it's raining. It has less vegetation or less NDVI when it's raining.
Well, the difficulty with this is that we're trying to map something in a temporal time scale, me defining when the wet and the dry season are, to then how this spatially looks. But it could just be that the definition of wet and dry season has changed over time. So then maybe it means that because we can't really see this greening in these months anymore, which is the wet season, it could just mean that the wet season has moved, and therefore my mapping of spatial and time scale are not 100% correct, which is something that I'm struggling a bit with, because I'm trying to split up my hypotheses around spatial availability, which is this one, and the temporal one, which is another one that I haven't included in this slide. But what this says for sure is that, for as far as we know, that in recent years, these are still considered the wet seasons. During the wet season, the availability of vegetation has decreased, which means that it's still a wet season, but it might be a less wet season than it used to be.
So when you say red, is that red compared to the prior year, or red compared to the rest of the?
It's just the slope of change over the last 25 years.
So it's a negative slope.
It's a negative slope over the last 20 years.
Or the last, I see what you mean. This is not showing absolute, but it's the relative slope of the green over the last 20 years.
Yes.
Exactly. Got it.
Yeah.
So you could start from basically 100, go down to 50, or you can go from 10 to 1 or 2, and then it's the same slope.
Exactly, exactly.
150, 10 to 5, sorry. Okay.
Yeah,
Got it.
So it's just showing the general slope over the last 25 years.
But I mean, isn't the slope, wouldn't the absolute change in vegetation be more interesting than the slope? I mean, as I say, if you go from 100 to 50, whereas you go from 10 to 5, so 100 to 50 meters, very lush, it went down to whatever, to green. Whereas going from 10 to 5, there was not much, it was not much now. If the threshold of at which you can have cattle graze is, let's say, 20 whatever units, then 100 to 50 means you can still have cattle there. You went from whatever. So it seems to me you want to somehow capture the absolute release.
Yes, probably. Yeah, probably there's something. I think the way I was thinking was to rather first classify the types of vegetation and see which types of vegetation, like is it fields or is it forests or is it like a certain type of other bushes vegetation that is useful, and then kind of map the slope of change within each category, because then they could be comparable, and now we're kind of comparing vegetation and dishes over whatever spatial feature that might be.
Okay, I mean, I think you'd be very careful with, I think Jacob has been struggling with this, so-called stock and flow variables, with the absolute amount versus the percentage change, and is it a percentage, is the, how do you measure it and so on. So you should talk to Jacob about this. He's spent a lot of time thinking about this.
I will.
So there's a question from James.
So have you compared it to like a biomass layer?
No, I have not yet. No, so far I've only looked at NPI, but that would be useful. I think there's definitely other layers I want to bring into this, but this is just what I've done for the last few weeks, 2 months. So, because before I was doing everything with the conceptual framework, and this is very recent. So then taking from here, there is the first part where I'm trying to do the spatial and temporal analysis, and then there's the other part where I was trying to predict NDVI based on, there's a lot of literature already on this, so I haven't really invented new models, but I've just used a set of variables that are used in existing papers. And then for Northern Ghana, one of these regions, try to predict the NDVI to see, can I link those changes in vegetation to specific changes in climate variables, because that's ultimately what I would be interested in. And then if I try to build up these instead of going with the complicated machine learning models as some of the papers we're using, I just use a really simple linear regression and try to decompose it into the components that I think would tell me something about which aspect might be driving the changes. So first I just used only a seasonal model, trying to see if the seasonal variability and a little trend maybe added into that can tell me something about how it has changed. And this is basically the plots that we're seeing is my linear regression model trained on the years 2000 until 2017, and then predicted on 2018 till 2025. So the simplest model we could potentially use. And then in the second one, I'm adding in the covariates like precipitation, temperature, solar radiation, wind speed. And then in the last one, I'm also adding in the NDVI from the previous month to see how that kind of explains part of my predictions. And we can see that in terms of R square, it performs pretty well, because almost all of my pixels are close to 0.9 R square. But on the other hand, if we look at the actual plots, they're all missing the peaks, which are maybe the points that we're more interested in. And then specifically for some pixels, I found it interesting. I haven't really solved this yet, but to see how it would reflect, like in this case, for example, in 2024, the two different peaks that we see in the NDVI are also in my predicted, but they're always a bit under predicted. So it's not like it's not capturing the characteristics, but it's not capturing them in the right amounts. And this is a bit work in progress. I'm just showing this to see where we're at the moment.
Yeah, I would suggest plotting the residuals.
Yeah.
So one trick that we use when doing this kind of work is when you plot the residuals, if there's a pattern in the residuals, then you can predict it. If the residuals look like Gaussian noise, then you have no hope, right?
Yeah.
So what you want to do is to essentially look at the correlation structure of the residuals. Right now, I can't make out the residuals well enough.
No, and I was planning to maybe pick, for example, 10 points that have the largest error between predicted and unpredicted, and plot them, compare them to 10 random points and see how far they are off, to see if it's just
I mean, the thing is, these outliers are very hard to capture. So don't go for the outliers, because they always have specific circumstances, whereas residuals are a structure you can analyze. So when we try to do this kind of, or I don't know if you've tried ARMA fitting or there's something called seasonal SARIMA, seasonal autoregressive moving average. So if you look at SARIMA or something called ARMA X, ARMA with external variable. These are the classical classical forecasting models. So the ones I've seen that are the best are SARIMA, which is the seasonal autoregressive with innovation and moving averages. And you put that model in, and you can actually just do it in R. You can just say, give me a SARIMA model and plot me the residuals. It'll just show it to you, and you see how close the residuals are to Gaussian.
Yeah.
White noise. If you get that, then basically it's a ghost time. You can't get that.
Yeah. Okay. No. I'll completely take that into account, and I think there's just few last slides only. Because this just has like this has a few other things that we were talking about, but probably looking at the residuals will maybe bring me closer to the answers of some of these where I was trying to wonder where the specific errors that I'm still having are coming from. Are they like coming from specific parameters that I didn't take into account because now I'm just using purely climate variables, right? For sure also aspects like urbanization will play a role in how NDVI has changed, or like the fact that I've kind of like working with a very coarse resolution of climate variables of ERA 5, while the NDVI resolution is much higher, and then I have to like downscale my NDVI or regional variability. And here I've just have a very indicated, because this I just plotted before this, where I've plotted basically the performance of my linear regressions per pixel, trained on that pixel, predicted on that pixel, and then you can kind of see the map of in which regions it's performing better and worse. And I want to compare this to like some of the parameters that I'm using to predict, to see if there's specific parameters that exhibit the better or worse prediction. But this is still very, very much work in progress to just kind of show like the small aspects that I'm trying to. Oh yeah, sorry.
I just want to check the top graph, is that for one chosen pixel? Or was it
Yeah, that's for
okay,
one chosen
or
pixel.
around?
For now, I'm just like, I've tried some models where I'm using neighboring pixels to be trained on and then predict on one pixel, but because the way that I'm downscaling my NDVI, it would just then kind of end up predicting the median for all of them. So I'm not really very, very far into this research yet. Anyways, if I quickly take this back to my initial conceptual framework, the idea would be that I slowly take each of these aspects as I'm now looking into pasture availability, try to link those with my hypotheses testing to the mobility trends, maybe do the same with road accessibility, where I talked a bit ago with Keshav about potentially trying to use the SERA to do some road detection, because this will also give an indication of where people have historically moved.
Tell us more, that looks fascinating.
And so this is basically taking a Google Maps of a city in Ghana,
Okay.
and then put the Tessera embeddings from the year 2023. I'm not quite sure next to it.
24, yeah.
24 next to it, just to kind of see if the roads that we would be interested in are visible. I think it's a bit too small to actually see, but the like big roads, the actual asphalted ones, are really clearly visible at the first instance. I haven't run any algorithms on this yet, but the small ones, which are the less asphalted ones, which are the ones that probably for my use case are going to be the most interesting, are kind of difficult to distinguish because they would lie somewhere in the blurb of the surrounding, like the spatial features are too similar, I think, from the actual regions where the cows and camels are grazing to distinguish the road from them. I'm not sure. But it's just like a first mapping that I did to see if it would be feasible or not, but I haven't done really research on it yet.
Yeah, you need ground truth for that. That's yeah.
Yeah, and we don't really have ground truth roads on that, because the best of roads that we have is maps like this, which I think mainly show the big asphalted roads and not the small ones that I would be interested in. And then we have a similar question with water availability. So there's still a lot of problems, and mainly in terms of data availability that have to be solved. But it was just an initial kind of difficult presentation to put together, because it's just trying to touch upon a subject that I think is not very much studied in literature yet, probably because of all the reasons of data unavailability, but I nonetheless think that it's very important to look at. Yeah. No, go ahead.
Sorry. Have you checked on OSM for any?
Yes, I have. And again, I think a lot of the roads that are being mapped are the roads that are being used by like cars and large infrastructures, and not as much the small transhumance routes that I'm looking at. And the ones that are mapped are mostly the ones that have changed into asphalted infrastructure afterwards, and are therefore not used as much anymore. So they might give an indication about roads that were historically used by pastoralists, but I think not the ones that are being used today, because those are not mapped in the same way usually.
There's sometimes some surprising regions where there's been like a
Yeah.
mapathon.
Yeah.
So
Yeah.
Any other? Okay, should we continue? Yeah. What is that, the last slide?
That's the last slide, sorry.
Okay, let's thank that. Any other questions in the room?
So this is kind of in the region of the Great Green.
Mhm.
Have you thought about how that might impact?
That would be.
Sort of running just to the north of the
Yeah,
lowest countries, I think.
I think I've been mainly trying to look at this region, like they're just below lower region where everybody's talking about the desertification narrative and then people just moving further southwards. So I haven't, in terms of like actual data and translating those dynamics, I'm still in the very, very early.
It'd be an interesting scenario.
Yeah.
Maybe you should explain what the Great Green Wall is, people here may not know.
I don't know the ins and outs, but it's essentially a lot of these just sub-Saharan countries to the south have clubbed together and they're trying to plant related vegetation essentially all the way across the base of the Sahara to sort of prevent desertification.
Yeah. But then there's also a lot of papers talking about how maybe some non-intended efforts, like for example, in my case, pastoralists moving further south and then leaving certain regions untouched for a couple of years actually might have had a bigger impact than these initiatives of actually planting vegetation, because it's just like land that has been untouched for a couple of years because they think it's not usable anymore, and then they would actually return or look on satellite imagery 10 years later would have regained itself, and then some of those natural I'm not sure, just papers that I've read, I haven't done any analysis, but those natural dynamics might be actually more impactful than the actually planned ones. Yeah, something that will hopefully come out, but I'm not there yet. It's a big topic.
Thank you. Any other? Are there any questions online? You can just unmute yourself if you want to ask a question. Okay, so I guess as this maybe finish by saying, the general context of this work I think is very interesting, because you have an actual complicated real world problem, and then you're trying to map that onto data. And I think the issues that come up, which is data availability, and then the complexity of the problem, that map you showed, the sort of causal graph which you showed, is quite complicated. And trying to figure out which arcs are causal, which arcs are not causal, and whether there are any confounding variables and so on is not straightforward.
No.
But I think the path you're in is a really good one. Looks like you have made some excellent progress here, and I think it's it can be very difficult to get all the way to the end. But even if you don't get all the way to the end, it's still worth doing this. And I think getting other people here to help you kind of think through these ideas would be great.
Yeah, I think the difficulty is definitely now, and like that's why it's a bit all over the place. And like I would be like, oh, I'm looking at the NDVI, and then I kind of forget I'm looking at the spatial aspect, but also the temporal aspect, and then the prediction aspect. And I feel like there's just so many different dimensions at play that I sometimes forget what the actual data problem is that I'm looking at for like a very specific aspect like the NDVI. And I would just be like, oh, let's try to make a prediction and question. Yeah.
Anyway, good luck. Thank you.
Thank you.
Thank you. All right, thank you very much.